All right. Good morning, everyone. Welcome to this webinar, an overview of AI ethics and governance. My name is Basil, and I am pleased to have with me today Professor Andreas Stettler. Good morning, Professor Andreas.
Good morning, Basil.
Right. Nice to have you. Professor Andreas is the Director of Data and Analytics at PwC Singapore, where he helps companies build trust in emerging technologies. Also, he is an adjunct associate professor at NUS Business School, where he teaches courses on technology, data value, and business strategy. Today is part one of a two-part series. It is being recorded, and we will have an abridged version of the slides available after the session. There will also be time for questions at the end, so do make use of the Q&A button at the bottom of the screen anytime you have a question, and Professor Andreas will address them after his lecture. So let us welcome Professor Andreas. Professor?
Thank you, and good morning, everyone. This is the first part of a two-part lecture on AI ethics and governance, and it is based on classes that I'm teaching at NUS Business School. So usually when I teach about AI, I start with explaining the foundations of AI, how it started, what it is, how it can be classified, the different technologies. I focus a lot on machine learning and deep learning, but also then go into GANs and reinforcement learning a bit at the end. And then I usually have a second part where I talk about industry applications, use cases, and then there's always a third part where I talk about risks, ethics, and governance, because I think that nowadays, as AI is getting more and more deployed in industry, and almost every company nowadays is using some form of automation and AI and machine learning, we also need to talk about what could go wrong. And there are many things that can go wrong, just to mention a few: fairness, explainability, security attacks. So I think when I speak to business people or future business people about AI, I always want to make them aware of the risks. But then I also want to tell them about the ethics or the responsible use of AI. And then more recent attempts to implement governance frameworks or implement controls for AI, to give them the full story on AI. So let me go into the presentation for today. Here's the outline. I will start with a view on AI as an existential risk. Now, that's not perhaps what most machine learning developers are usually concerned about, but as you probably all are aware, there's a lot of debates in the public space about how dangerous is AI really? How does it compare to other existential risks? What about superintelligence? What about AGI? So I think just to give you the complete picture, I will have to talk about that a little bit. But I think the main focus of the first part of today's lecture will then be on more concrete risks and more present risks related to opaqueness, unreliability, bias, adversarial attacks, job displacement, and ethical misalignment. These are all very real risks that are being tackled and where some solutions exist, but others do not. And then going from the risks to ethics, I will tell you about typical ethical concerns as raised by philosophers. And that will then transition into a discussion on AI safety, which has really only been around for a few years and became mainstream in around 2015. The Future of Life Institute was quite instrumental in that, with organizing a conference. And ever since 2015, we have seen an outpouring of ethics frameworks from different organizations, companies, even governments. I will not have the time today to give you an overview of all of them because there are more than 100 now. So I will try to condense it into key principles. And it turns out that if you do this meta-analysis, that there are 5 themes of ethical AI that occur and that are relatively consistent across all these different ethical frameworks. But then at the end of today's lecture, I will also make a point that principles are nice because they give us a framework to think about AI in an ethical way, but they're not sufficient to guarantee ethical AI. So that's then where you need to start thinking about governance, control, which will be the topic of part 2. It's not that the awareness of the risks of AI just started a few years ago. In fact, Alan Turing already talked about it in a radio address in 1951. That was 4 years, if you remember, before the word artificial intelligence was even coined. And then the famous Dartmouth Summer School was held in 1956, which started AI as an academic and research discipline. But in 1951, Alan Turing said, if a machine can think, it might think more intelligently than we do. And then where would we or should we be? Even if we could keep the machines in a subservient position, for instance, by turning off the power at strategic moments, we should, as a species, feel greatly humbled. This new danger is certainly something which can give us anxiety. So he touches on several points here that are still being debated nowadays by scientists, by philosophers, on how do we keep in charge? How do we make sure that there's an off button that we can use at certain moments? How do we make sure that we are not then at some point controlled by machines? Philosophers call this the control problem, and it has given rise to a lot of activity in the academic space, but even in the public domain, you will see a lot of discussions about this. Now, one way to look at it, and that's taken from a very recent book by Toby Ord called The Precipice. Now, it's kind of ironic that this is a book about existential risks like pandemics and economic catastrophes. And I don't know how long it took him to write the book, but it turns out that when it came out in March 2020, we were in the middle of a pandemic and we were at the start of a worldwide global recession, economic recession. So that just shows you how sometimes these prophecies become true. Now, he didn't just look at pandemics, he also looked at other existential catastrophes, and he tried to assess the chance of them happening within the next 100 years. Now, don't ask me how he came up with these numbers. In fact, I haven't read the book yet. It's on my reading list. I just came across this table, which is from the book. So we would have to go and actually read the book to sort of understand the methodology on how he came up with these chances. But just to put it into perspective, so he distinguishes 3 natural risks: asteroid or comet impact, supervolcanic eruption, and stellar explosion, which then, if you weigh them and put them all together, you have about a 1 in 10,000 chance of something like this happening in the next 100 years. And then he has a long list of anthropogenic risks, so man-made risks, starting with nuclear war, climate change, other environmental damage, naturally arising pandemics, engineered pandemics, and then what he calls unaligned artificial intelligence. And what he means by unaligned is that this is AI that is not aligned with human values, that somehow then becomes super intelligent in some way and takes control and then leads to widespread existential risk or maybe even not extinguishing the human race, but dangerous to our way of being. And then when he adds all of that up, he gets about a 1 in 6 chance of something like this happening over the next 100 years. Now that's not very reassuring, I would say, and I definitely want to find out how he came up with these numbers. What I found surprising when I looked at this list is that, first of all, the risk of climate change seems relatively low to me. I mean, just based on other books that I had read. So I would want to understand why, in his view, it's only 1 in 1,000. And I did think that 1 in 10 for unaligned AI is actually fairly high chance of this happening and leading to existential catastrophe. Again, existential catastrophe doesn't necessarily mean that it's the end of the human race as we know it, but it could mean the end of certain ways of doing things, or it could mean societal disruptions, it could mean war. So there are many things that can happen, but this is just to give you a perspective of how AI compares to other existential risks in the view of Toby Ord. Now, one person who has thought and written a lot about the long-term implications and future of AI is Stuart Russell. Many of you may know him as the author or the co-author of the standards textbook on AI or machine learning, together with Peter Norvig. On his webpage, Stuart Russell writes, as the capabilities of AI systems improve and as it transitions into broad areas of human life and business, I should add, this obviously leads to huge increases in research that is done here in Singapore, but also more and more companies in the private sector. And so we have to begin to take this more seriously. The basic assumption over the past 50 years or so has been the more intelligent, the better. And Stuart Russell questions this basic assumption. He says, well, shouldn't we also be concerned about the benefit of humanity? Maybe at some point, the more intelligent will not be better, especially when we reach the point of superintelligence. So he says, we need to do something now, when we're still many decades away from AGI or superintelligence, to then really be ready and be prepared when it happens. So we need to really seriously talk and do research on control and safety. And we need to do this in a multidisciplinary way. It's not just a topic for computer scientists, and it's not a topic definitely for not only for philosophers or ethicists. It really has broad implications. So Stuart Russell wrote a book called Human Compatible Artificial Intelligence and the Problem of Control. Came out last year. I highly recommend it. It's a great book. It's very approachable. He doesn't just talk about this topic here. In fact, he also talks about the history of AI and what we know about human intelligence, all the research that has been done by cognitive scientists and psychologists. And he has one chapter, which I have summarized here on 2 slides, on what he calls misuses of AI. But we also could call it societal risks or existential risks of AI. The first category is on surveillance, persuasion, and control. And that should be familiar to all of us who are in AI development or who are reading and teaching about AI. I mean, even today's systems, while they are narrow in what they can do, they are very good at understanding the content of what we are saying and doing. Not understanding at a higher level, obviously, but at sort of a purely cognitive level, you know, the text, they can really be used to surveil us 24/7. Now that then leads to business models that have been called surveillance capitalism by other authors, where our data is at the source of behavioral profiles, targeted advertising, tracking, facial recognition. So all of that is part of this new business model using data and AI. And then if you have so much data, obviously from individual sources, you then have what we call data brokers who are businesses that do nothing but just integrate data from different sources, aggregate it, clean it, and then sell it to others for a good markup. So there's an entire data economy that has emerged over the past about 10 years to just feed these machines that need more and more data, especially unstructured data, to make predictions, which then can be sold at a price to advertisers and to other companies who want to know who we are and what we want to do. Because Russell makes a good point here that this is not just about knowing who you are. Essentially, it is then also at a point to modify your behavior. And we can already see that happening in social media, not just through targeted advertising, but also through disinformation, even to the point of propaganda. And there are many examples here, and I'm sure you have read about them yourself. And then one area that's more specific and where Russell again has been at the forefront of these discussions is lethal autonomous weapons, which are defined as weapon systems that locate, select, and eliminate human targets without human intervention, fully autonomous. And people have described them as the third revolution in warfare after gunpowder and nuclear weapons. And I think there's an awareness in diplomatic circles and government circles that something needs to be done. So in fact, since 2014, discussions are underway in Geneva for a treaty to ban autonomous weapon systems, similar to a treaty that was implemented many years ago to ban biological weapons or chemical weapons, and similar to a treaty that didn't ban, but at least contained the buildup of nuclear weapons. So work there is happening, but I think we should be aware that this is also big business. And we see companies like this Israeli company that is mentioned in the book by Russell that is selling what they call a loitering munition system. So think of this as a drone, few meters wide, few meters long, can be launched from a truck, and then it is sent to the battlefield and just circles the sky, waiting for something to happen. And then once it identifies a target, it can dive down and detonate upon impact. So this is not equipped with any guns. This is the projectile. And I guess the concern about these kinds of weapons is that, yes, they are still mostly guided by humans, but they can be given as much independence and autonomy as you want, right? If they circle for several hours on the battlefield just waiting to dive down, then there's no point supervising them all the time. They will just decide autonomously what to do based on how they're programmed, which is obviously a risk that needs to be governed very carefully. Then two other categories of misuses that Russell talks about in this book is work. I think I'll come back to that topic, but just for now, there's many papers, hundreds of papers have been written about the topic of displacement of work and labor market impact of artificial intelligence and automation. And most economists actually would argue that overall, automation is a good thing. And there's historical proof for that automation increases productivity. So humans as a whole are better off. However, and that's the problem, the cake gets bigger, but not everyone participates in the same way. In fact, it turns out that when you look at historical data, that automation tends to increase the share of income that goes to capital and decreases the share that goes to labor. And I will show you a chart on the next page, how this can then reflect itself. If we think beyond, or if you look at what's happening now, I think it's very clear that as AI gets better and better, at some point, all routine physical and mental labor will be done more cheaply. So then I think we need to take a decision. Do we just want to stop working? Do we just want the machines to take over? What then does that mean for us? What kind of jobs are still left? And again, so there are analyses on this already, and I will show you just one or two examples today. A lot has been written about that. But I think there's also a growing awareness that if there is large-scale displacement as a result of this automation, if hundreds of millions of people lose their jobs, then what are they going to do, right? There's still maybe work for them, but it will be below the poverty line. And so then you need to think about, as a government, what are we going to do? So the topic of UBI, universal beneficial income, is now being debated. If you recall the US presidential election, one of the Democratic candidates who has since dropped out of the race, Andrew Yang, he was one of the proponents of UBI, also as an answer to the risk of large-scale displacement of work through automation. And then even if we stay in the jobs, then it might actually be demeaning or diminishing our authority or our autonomy, because it could mean that in this future type of work, some or large classes of people no longer really work for humans, but they then work for machines. So you would have sort of Russell calls this a separation between an elite, which is served by humans, and then a vast underclass, which is served and controlled by machines. And again, this is, this sounds a bit pessimistic and also futuristic, but it is not. I mean, you can already see right now, I think COVID-19 is a good example where, if 90% of the workforce is at home, how do you control them? How do you make sure that they actually do work and don't surf the web or watch YouTube all day? And it's well known that companies are or have deployed software to monitor their employees. And now you might say, well, we live in special times. Once this crisis is over, this will go away, but then maybe not. Maybe it's there to stay. So I think that's a great concern to Russell and to others. How do we make sure that we don't lose human dignity as machines, algorithms take on more and more responsibility, even to the point where they manage people? So here's a chart that I was alluding to before on what they call decoupling between productivity, so that's the straight line, and real wages. It goes all the way back to 1947. That's US data, so obviously Singapore will look different. I have not seen any similar data from Singapore or other economies, but the US labor market has been analyzed a lot. So you can see that, in this indexed view, between about 1947 and the middle of the 1970s, productivity and wages or earnings increased in tandem. The new technologies were installed, the economy became more productive, businesses became more productive, and as a result, human workers earned more. But then, sometime in the 1970s, these two charts diverged, decoupled from each other. And to be honest, I mean, there are many explanations, but there's not one simple explanation why this happened. But most economists would argue that automation is a part of that. And as I said before, automation tends to increase or tends to make those who hold the capital better off than those who actually work. And so this could be reflected in this chart. And it hasn't really improved ever since. So for the past 40 years or so, real wages of workers have just been stagnant. Whereas on the other hand, those who owned the technology and those who led the transformation became very rich on the way. And I'm not here to criticize this. This is just I would say, a reflection of the capitalist system. But I think in the long term, if this continues to decouple from each other, there could be societal impacts that just need to be addressed somehow. So this is just a very brief outline on existential risk, but obviously there are many other risks that we need to take into account. And I was looking for a structure that gives an overview of all the risks related to AI. And I found one that I thought was actually quite good on the website of the Partnership on AI. The Partnership on AI was founded in around 2016 by the big technology companies. So it is sponsored by private sector with the intention to work on AI ethics, security, safety, and they have, so you can have a look, they have a pretty good sort of overview on what are the issues and risks of AI nowadays. They have different pillars, and in each of these pillars they define risks of AI that I think align quite well with my own understanding of the risks and my own conversations that I'm having with clients on AI risks. The first pillar is safety critical AI, but I say that, you know, if AI tools are replacing human decision making, as they do, as you know, we must be sure that they are safe, trustworthy, and aligned. So that's a big focus of research nowadays, of yourselves and others who are working on AI and safety. But then, in addition to that, there's also the question of how fair is all of this? How transparent is it? And that's a big enabler, obviously, also for trustworthiness. Because if we don't understand what's happening, then how can we trust it? So there are many examples, and I'll show you a few, and I'm sure you're aware of many others, where AI has led to biased decisions, has discriminated against protected groups. So that's a problem that has attracted a lot of attention by not just technology companies, but others as well, and is a sort of a big pillar of many of the ethics frameworks that have been published. And then this is what I already talked about, just sort of formulated in a different way: labor market impacts, economic, macroeconomic impact. I think that's clear that this is something that needs to be addressed, but this is probably less a problem for technology companies or AI researchers. This is more something that policymakers, governments need to do. And I think we can see right now in Singapore is a good example of how the current economic crisis is also an opportunity, or seen as an opportunity, to work on upskilling and to sort of accelerate this digital transformation of the society. And obviously education and training plays a big part to prepare people for a digital future and a digital workplace. As humans and AI start to collaborate, there's also the question of how do we understand, how do we trust them, how are we confident that they do the right things. So this is also goes a bit back to transparency, and also, you know, many books have been written about that. This how AI augments human capabilities, human and AI, and this sort of collaboration in a corporate environment. And again, I think Singapore is doing work along these lines to do task-based analysis to see what kind of tasks will be automated or augmented, and what does that mean for the workplace. And then, as a last pillar, impacts on privacy, democracy, criminal justice, human rights. Again, there are many examples of how AI is used for very critical and high-risk decisions. There have been privacy issues or compromises, not all of them in the context of AI, but I think as big data and AI become more and more widely adopted, then obviously privacy and data protection will become even more important. So let's look at a few examples of how these risks manifest themselves in the business world. And these are examples that I usually use in the business school because they're relatively intuitive and easy to understand. But they also make the point that companies that have implemented AI or are implementing machine learning models often face problems And this is one example from BlackRock, the world's largest asset managers. So they have liquidity risk models like every asset manager, every bank, and they have had these conventional models that did relatively well, but then they started developing neural networks. And the performance was extremely good. They were happy with the performance, but they couldn't understand it, or they couldn't explain it to senior management, right? And now you all know that this is nothing that we can do much about it. I mean, you can use explainability tools, global or local explainability for neural networks, but even then, to explain this in plain language may be challenging. So they then just decided, you know, we don't go through the trouble of doing this, we just stop using these models, even though they're better than conventional models. And then this is something that led to a lot of, I would say, public attention when it was published in 2016 by ProPublica, a US newspaper, online, a newspaper on Compass. And this is even though it's already a few years old, this is still sort of the prime example of unreliability and bias through AI. Now, one thing that I always say when I teach this example or talk to corporate clients about this is that Compass is not a sophisticated tool. It's not machine learning. It's more like I don't even know what kind of model they use, whether it's tree-based or simple kind of prediction model. But you can also just think of it as some weighted risk assessments based on 137 features that they collect from individuals. And then they try to predict with this model the risk of recidivism, which means to commit another crime within 2 years of assessment. So everyone who gets booked for a crime, gets arrested, gets a score, a risk score. And the risk score can determine things like, you know, how long are they held in custody, and can have a big impact on people's lives, right? Because if they have a high risk score, they will be more highly monitored. So what ProPublica did is they were able to obtain the actual risk scores from more than 7,000 people that were actually arrested. And then they looked at other statistics and reports to assess how accurate were these predictions made by Compass on the risk of recidivism. And they found out that, well, they're not accurate at all, right? So highly unreliable. Only 20% of the people where the model predicted that they would commit another violent crime went on to actually do so. So it highly overestimated the risk of recidivism for violent crime. So that's obviously already an issue that, you know, why do they use a model if it's that accurate? But then there's another issue, in fact. The error of the model was biased. It was overestimated for one group and underestimated for another group. So concretely, one type of prediction error is where the model says this person is high risk of, again, committing a crime. And so it turns out that African Americans were twice as likely to be labeled higher risk, but didn't reoffend. If you look at the other source of error, where it's the other way around, I guess you could call this a false negative, so labeled lower risk, but did reoffend. So in this case, the risk was underestimated. In this case, it's exactly the other way around. So whites were twice as likely to be labeled lower risk than African Americans. So there's a clear case of racial bias here. But then, and you know, there's a lot of literature that has been written about this. Compass claims that we agree with these figures, but overall the tool is still unbiased because they they use a different measure. Now, one of the problems with fairness, and I'm sure you're aware of this, is that there's not one single measure of fairness. In fact, mathematically speaking, there are more than 20 different measures, and some of them are even mutually exclusive. There's always a trade-off between fairness and other measures. And so what companies can do, and what you can do with commercially available or open source fairness tools is you can kind of weigh these different risks against each other and do an impact assessment. So here's just one example to illustrate how this works in a Compass example. So on the right, we have a case of a young Black woman who was considered high risk by the model based on something she did. You can argue that this was already not justified to arrest her and a friend for just using a bicycle that was lying around. But again, so she got a risk score of 8. And then on the left, we have a white man who was also arrested for a much more serious crime. But he also had prior offenses, but he was considered low risk. Right, so she had just misdemeanors. He had been convicted of armed robberies. And so that's already not really understandable why she was rated 8 and he was rated 3. And then if you look 2 years into the future, it gets even more confusing because she then didn't commit any other crimes or misdemeanors. And he was charged with grand theft and serving an 8-year prison term for breaking into a warehouse. So you can see that there's an obvious problem here, but the company that developed Compass wasn't really acknowledging that. I mean, they were just arguing that, yes, but we used a different measure, and in this different measure, the model is actually fair. A more recent and also widely discussed example of bias, in this case it was biased against gender, comes from Amazon. Embarrassingly, Amazon is one of the big AI companies, and so it's not surprising that they used AI for recruiting. They had been using it for many years, already starting in 2014 to do screening of candidates. And that's not just Amazon. Many companies are now using AI for recruiting, screening, evaluation, and Amazon built their own tool, I assume, because they have the capabilities. But in 2018, they found out that this tool had been systematically biased against women, and they had to pull it off. They had to stop using it. And it's easy to see why this happens, because the tool, the neural network, was trained on historical data, 10-year data, and it just so happens that men were obviously overrepresented in this training data set compared to women. And what the model then did, as every statistical model would, if it's not adjusted correctly, it just kind of extrapolated into the future and assumed that, not that the model makes any assumptions, but just statistically assumed that this had to be right. Not just Amazon, Apple had also a bit of an embarrassment in last year, actually. So they introduced a credit card called Apple Card in the US. And Apple just did the branding, the marketing, but the technology was actually developed by Goldman Sachs. And the underwriting and also the booking of the loans was done by Goldman Sachs. But then sometime in the fall, people started noticing that strange things about this underwriting algorithms. One person pointed that out on Twitter, that for some reason, he had 20 times the credit limit of his wife, even though he and his wife had the same address, pretty much the same income, the same credit history, but for some reason, his credit limit was much higher than his wife's. And even Steve Wozniak, who you probably know was one of the co-founders of Apple together with Steve Jobs, he then also said, well, exactly the same happened to me. I also have a much higher credit limit than my wife. What's happening? What's going on? Yeah, it's a big embarrassment, not just for Apple, but also for Goldman Sachs. And this is not just a public image disaster, but this also may have regulatory implications because the New York Department of Financial Services then started an investigation into this and Goldman Sachs' practices. Now, there's an interesting article in Wired magazine that you should read if you're interested in this, because they then they tried to find reasons or explanations why this happens. And Goldman said in their defense, well, two things. First of all, we had an independent third party, an auditor, that vetted our model and they cleared it. So I would say that's good, right? For high-risk models, you should always have them audited by a third party. That's also a recommendation that PwC here in Singapore makes in the Model AI governance framework. But then they also said something else. They said, we didn't use gender as an input variable or as a feature. So how could we discriminate if the model doesn't even distinguish between women and men? And well, you don't need to be a PhD in machine learning to see that this explanation is deeply flawed, because there might be other features, and there usually are, that correlate with gender. Even if you remove gender from your data set, if you just delete the column, you will still have gender information in there. It's a bit like a similar case that happened in the US many times, where they took out racial information so that the model wouldn't discriminate against race, but they left zip codes. And it's very clear that, in the US especially, that zip code is highly correlated with race. So you could still have discrimination in the model. So the recommendation actually by developers and auditors is that do not make your model gender blind. Leave it in, because then when we want to audit it, it will make it easier for us. If there is no gender information in there, if it has been deleted, it makes the audit more difficult and less effective. So I've talked about bias a bit, and here's one other example. I'll go through this relatively quickly. I'm also using this in my teaching at NUS to sort of introduce the concept of facial recognition and to introduce the concepts of one-to-one and one-to-many matching. But many of you are probably familiar with this, so I can just skip through this. But this study by NIST, which was published last year in December, is actually very illuminating, because they looked at 189 algorithms from 99 developers. I guess you could argue that that's pretty much all the facial recognition algorithms out there. I think the only major manufacturer that didn't participate was Amazon for some reason. And then, as you know, there are two types of matching or facial recognition one-to-one, which is what you usually use for unlocking a smartphone or checking a passport at the border. And then there's one-to-many matching, which is used by law enforcement a lot. It turns out that when they measured the accuracy of these 189 algorithms and found out that the accuracy is not very good, in fact. We have false positives and we have false negatives, but similar to the Compass case that I described before, we have geographical and racial differences in these matchings and in the false positives and false negatives. So, for example, we know when you look at one-to-one matching, much higher rates of false positives for Asian and African American faces relative to images of Caucasians, and actually the difference is orders of magnitudes, 2 or 3 orders of magnitudes, and depending on the algorithm. So one-to-one matching, I mean, that's maybe not so much a concern, because it could just mean that you're not recognized at the border control, or you're unable to unlock your phone. So maybe we can gloss over that, but obviously the bigger issue, probably in a societal way, is one-to-many matching, because that's what's used for law enforcement. And there the analysis showed that much higher rates of false positives for African-American females. So that's obviously bad news for African-American females, but because it means that there's a much higher possibility of them being matched with, for example, the criminal database, even though the matching is wrong. It's a false positive. Interestingly also, for us here living in Asia, the algorithms that were developed in Asian countries, obviously a lot of them in China, but also outside of China, did not show these differences. They were much better at matching consistently across Asian, African American, and Caucasian faces. So I don't know why that is actually. Perhaps there's a greater awareness of this in Asian countries because they are more multicultural, or because they have better data sets. But it just shows you that the data sets play a big role here in calibrating these models. And then one of my favorite topics, which people in the business world always find very amusing, is adversarial attacks. And this is an active topic of research. So this is from one of the earliest papers by Ian Goodfellow and others from 2015, where they used an image recognition model, fed it with a picture of a panda, well, as we know, which was in fact recognized as a panda with 60% confidence. Then they added a little bit of carefully constructed noise. So the image gave it back to the model, and this time the model said, no, that's a given. And in fact, I'm 99% sure. Now, obviously, they knew what they were doing. They knew exactly, how they could attack the model and how they could change the prediction. I find that fascinating. There are other examples like this, where they took a stop sign here, standard stop sign. They put 4 stickers, 2 black ones, 2 white ones, and suddenly this was no longer recognized as a stop sign, but as a speed limit 30 miles per hour. This is in the US. And well, if you own an autonomous vehicle, then that should make you worry, because stop signs aren't always clean. Sometimes you have graffiti or you have stickers like this. So what if, I mean, that's a real world example. This is not, the one on the left is not modified. It's just an example of what can happen in real life and the kind of unclean stop signs we have. So that's obviously a concern. Now, one thing I should say about that I always emphasize when I talk about adversarial attacks is that nothing like this has happened yet, as far as we know, in the business world. All of these examples have been carefully constructed by researchers, and we have not seen them yet deployed by actual malicious users or attackers. But then maybe they have, maybe we just don't know. So here's an example from YouTube. Let me just maybe show you this if I can. I have the video open. It's quite amusing. And some of you may have seen it. It's a very short video. It's only 14 seconds. So make sure you watch what happens. So that was it. So what happened here, and you can go and read the paper about it, is that they constructed what they call an adversarial patch, which is like looks kind of a psychedelic picture of something, to make the model believe that this was no longer a banana, but a toaster. And if you're interested in this and want to know more about it, there's a paper on archive.org, which was published in 2018, called Adversarial Patch. Good, so that's all about adversarial attacks. Again, I think the good news is that they're not yet seen in the real world. It's more laboratory conditions and research. So let's turn our attention to automation and displacement of work. I said many studies have been done here. This is a more recent one by the McKinsey Global Institute, and they came to the conclusion that across all the jobs in the world, about 15% could be displaced by automation. However, obviously, if you take training and adaptation into account, they estimate that really only 3%, or 75 million of global workers, would have to change jobs as a result of automation. But they also make it very clear that, and I think Singapore is also very conscious of that, workers will need to adapt as the occupations evolve alongside increasingly capable machines. Some of that will be through education, but some of that will also be just be aware that what are the skills where humans are better than computers or machines? Social skills, emotional skills, creativity, and high-level cognitive abilities. So teaching, management, arts. So there will be movements, there will be developments in the labor force to counteract the effects of automation through AI. Here's a study that was published in 2018 that just looked at the 6 largest economies in ASEAN. I would say similar figures. So if you recall, McKinsey came up with 15%, the midpoint average globally of potential displacement of jobs. So for ASEAN 6, it's a bit less, it's about 10%. But then there are big differences across the different economies. Indonesia, Malaysia, 7 to 8%. Singapore, more than 20%, which shouldn't be surprising if you look at how the Singaporean economy is structured. Again, I'm not saying that 20% of people will lose their jobs because of automation. That's not at all what these authors are saying. What they're saying is that there is a risk of displacement through automation. So you need to prepare, you need to upskill the workforce, and institutions like AI Singapore do a lot through their training programs to contribute to upskilling the labor force in Singapore and make them not just aware of these tools, but also enable them to use data analytics, visualization, and even machine learning tools. But then, if you look at other studies, it's really, really hard to predict. Right? So this is McKinsey. You can see the high scenario, low scenario. PwC produced some numbers that were somewhere in between. Others came up with other estimates, so Bank of England. So I don't know about you, but I don't really see any kind of correlation or trends in these figures. So this is just to show you that, yes, there will be an impact on the labor market, but it's very, very hard to predict. Ethics or moral decisions. And this has come into the public attention mostly in the connection of self-driving cars. The question here is, how should we program self-driving cars so that they are ethically aligned with human values? And this is taken from a science paper, 2016, where they looked at cars that were programmed according to a utilitarian philosophy or course of action, which means that the car should behave so that it causes minimal harm to society or humanity. So, for example, in the scenario A, in a utilitarian philosophy, the car would need to swerve so that rather than killing a lot of people, it would kill one on the side, and one is less than many. So that's what it should do. And then here in scenario B, it should swerve as well, potentially then harming its passengers. So that's a point where, so if there's no one in the car, it's clear what needs to be done. But what if there's a passenger in the car? You can already see the kind of dilemmas that arise. And C is even more complicated, because what if you have several passengers in the car? What do you do? So the authors here asked people about their opinions. First of all, they asked them, what do you think of the utilitarian doctrine? And everyone said, yeah, absolutely. Cars should be programmed so that they save the maximum amount of lives or harm the least amount of lives, according to utilitarianism. But then they also asked him, well, would you buy such a car? Would you buy a car that is programmed to, in an extreme scenario, kill you or sacrifice you to save others on the street? And then they said, no, absolutely not. I wouldn't do that. If I buy an autonomous vehicle, it needs to be programmed first and foremost to protect me as the passenger. So you can already see from this simple example, which has since been replicated many times, that it's not clear cut. It's not so easy. And it will be difficult really to convince people over the next 10, 20 years as we move to autonomous driving and autonomous vehicles to give up this autonomy and just trust the car. And also to deal with the notion that, or deal with the scenario that the car could, in some extreme cases, sacrifice passengers at the expense of many people saved on the street. So that's one example. And then many of you may know the moral machine experiment that was conducted by MIT. There's the platform is still open. You can still go there and do the test yourself. I mean, I've done it with students as well, just to give them an introduction to the kind of ethical dilemmas that arise in the context of self-driving or autonomous vehicles. And so this is a typical kind of decision you would have to do in this experiment. Again, these are self-driving cars that have a brake. So the brake doesn't work. And so the car can only do two things. It can go straight or swerve. This is an adaptation of the trolley problem that some of you may have seen. And so this is, there is no right and wrong here. It really depends on your own kind of moral compass and what you would do. And that's also what they found in these experiments. They found that there are certain preferences. For example, the participants would spare females over males, fit over the large, higher status over lower status. So all of these preferences could be measured through this moral machine. Also relative preferences, all the way from stroller to cat. The most interesting thing that I've found about this experiment was that they clustered the findings into geographical or cultural clusters, into Western, Eastern, and Southern sphere. And you can really see significant differences between how people judged these scenarios based on where they were from or how the kind of culture that they represented. So for example, in the Western sphere, there was a much bigger and much more pronounced preference to sparing the young than in the Eastern sphere, where we live here. And I think it's clear that if you compare the Western and the Eastern sphere, that here the older people are respected, and so they much more, I would say, than they are in the Western hemisphere. So there would be a higher chance or a higher preference of protecting them from harm than here. So that's one example, and you will find many other examples here, which tell you that it's not so easy to just program moral decisions, because there are these differences in how these decisions are made. And you can't just program a car with some kind of global logic and then expect it to behave consistently across the world, because there are these differences. So that's what I had to say about risks, both the existential risks and then the more short-term risks. And this is how ethicists think about this. Basically, we have spoken about that already, so I don't need to repeat it, but this is just to give you a different kind of vocabulary. Inconclusive evidence, is one concern. Inscrutable evidence, which has to do with the black box issue. Misguided evidence, which we saw in the context of the criminal risk assessment. Unfair outcomes. Transformative effects, traceability. So all of these are then ethical concerns that need to be dealt with, not just by ethicists, but by companies as well. And this is the reason why we have seen such a rise of ethical principles and ethical frameworks in the past few years. Let me go back to the presentation. So how did it all start? Why is it that we now have more than 100 ethics frameworks for companies and governments and organizations? Why did this suddenly become such a big topic in machine learning? Well, actually, I would say that it's not really totally new. Norbert Wiener, famous mathematician and one of the pioneers of AI, already said in 1960 that if we use a mechanical agency with whose operation we cannot interfere effectively, which is probably true about many machine learning tools that are being developed, we had better be quite sure that the purpose that we put into the machine is the purpose that we really desire. So this is how he expressed this, what I called alignments between the objectives of the machine and the values of the human users. The Future of Life Institute was founded in 2014 by Max Tegmark, a cosmologist from MIT, with, I think, seed money from Elon Musk and others. And the Future of Life Institute, I would say, was quite instrumental in bringing these topics of safe and beneficial AI to a broader public. It started with a conference in Puerto Rico in January 2015 called The Future of AI, Opportunities and Challenges. You will recognize many famous machine learning researchers, business people, academics from all different branches, including economics and law, on this picture. It's the first time really that in an academic environment or sort of a multidisciplinary environment, people came together for 2 or 3 days to talk about AI. And all of this is online, so you can go there, you can watch the videos. It's quite fascinating, actually. Many of the statements that were made back then still hold true. not much has changed in this regard. And then, you know, throughout 2015, a lot happens, a lot of publications and activity and open letter after the conference was published on the progress of AI and that's how important it is to also maximize the societal benefits of AI. So that was the first time that all of the concerns that researchers had been having about AI were expressed in this way. And the letter recommended, not just recommended research, but also actually came out with a draft proposal on the kind of research topics that should be worked on, which was published by Stuart Russell and others. And still there, you can see that I think it's still a valid kind of outline of research that needs to be done and research that is being done nowadays by many different institutes and academics. They also emphasize the point, which I strongly support, that this research has to be interdisciplinary. It has to involve not just AI developers, but also business, social science, law, philosophy, security, mathematics. All of them have come together. And some of the work that I do at NUS is very much along these lines, because at the business school, we also have now scholars and researchers who are not just interested in AI as a solution to business problems, but are working on these more higher level questions of robust and beneficial AI. So if you support that, statement, in fact, you can sign the open letter. You can go there to the website, you can see who else signed it. You will find many famous names of machine learning developers and researchers. So you can add your name if you want. And so the period between 2015 and after this Puerto Rico conference in 2017 was really, I would say, was just the beginning of AI ethics as an interdisciplinary field, where institutes were founded, non-profit organizations came into existence. The Future of Life Institute, that was one of the first to really bring this to attention, was actually already founded in 2014, before the Puerto Rico conference, and then another institute was the Center for Human Compatible Artificial Intelligence at Berkeley, where Stuart Russell is a professor. Then we had 3 institutes in the UK. All of them are still there. All of them are still doing work. The Future of Humanity Institute at Oxford, the Center for the Study of Existential Risk in Cambridge, and the Leverhulme Center for the Future of Intelligence, also at Cambridge. And in addition to these academic institutes, we also saw the partnership on AI being created in 2016 between Google, Facebook, Amazon, Apple, and others, so the big technology companies that said we need to come together and we need to put some money into this topic of safe and beneficial AI. And if you recall the pillars that I showed in the first part of the lecture with the risks, that was taken from the partnership on AI. So 2 years later, another conference took place called the Beneficial AI Conference in Asilomar, California. You can already see from the picture that probably about twice as many people as in 2015. And so it attracted even more interest. And at this conference, they didn't just meet for a few days and talk. They also came out with a list of principles. A list that was developed through a fairly structured, top-down, iterative process. And these 23 principles became known as the Asilomar principles. And I would say that they are still the foundation of many of the ethical frameworks that we have seen in AI since then. They're still kind of the benchmark against which other principles are measured. Let me just show them to you. I mean, I'm not going to go into all 23 of them. I will show you a more condensed view of ethical principles, but just so you know what we are talking about. They have 5 principles devoted to research issues. So repeating and re-emphasizing what I already mentioned before, that it shouldn't just be undirected intelligence, but beneficial intelligence. And then the funding obviously should cover all the different fields of research, not just computer science. There should be a link between science and policy. And I think here in Singapore, we see that to great effect, the kind of links we have between the universities, AI Singapore, the private sector, and then government institutions like IMDA and PDPC who have worked on governance frameworks on AI. I mean, a lot of that activity I think is happening here in Singapore between science, the private sector, and policymakers. Research culture, I mean, that's basically just what you would expect, right, from research, and they also stress that, you know, this shouldn't evolve into a race to the bottom, right? We should avoid cutting corners on safety standards just in order to be the first or in order to make the most money. They really appeal to our sense of morality and sense of responsibility when it comes to deploying and developing AI. And then we have several principles that they have collected under ethics and values, starting with safety. This all pretty much started, this discussion on AI started with safety, but then it also evolved into more principles and into a wider area. Transparency, which we now call like explainability. They divide it into failure and judicial transparency, responsibility, obviously, value alignments that I mentioned before, human values. Privacy is a big topic that needs to be considered in every sort of AI implementation. And so on. I mean, the list is very long, I have to say, which is one of the issues that I find with the Asilomar principles. Is almost too much, right? I mean, 23 is much more than you can handle. And even though I greatly respect the structured process that they use to come up with this list, it's not one that I use often in my work, just because I find it I just find it too long, to be honest. So I think that the European Commission guidelines, for example, or the OECD guidelines are much more tractable and much more condensed. Longer term issues, again, this is something we have spoken about already. So Asilomar, that was the start, and then many others followed. In fact, in part 2, I will give you a bit of statistics on how many guidelines there are as of latest counts. And there are actual institutions that collect guidelines and that do this sort of meta-analysis across the different guidelines. But this is one that I'm using quite a lot, actually, as a reference point when I talk to students, when I talk to companies from my own work. The ethics guidelines for trustworthy AI that were issued and published by the European Commission in April 2019. I think it's an excellent document. I recommend you read it. The reason why I like it is that it's not just a list of ethical principles. They actually have a structure in there to go from principles to practice. And that's what I will mention in part 2 of my lecture, how you do that. Here, for today, I will just give you an overview of what it is. And then next time, I will go into more detail and tell you how they were able to translate that through a consultation process with industries into actual recommendations on how to operationalize these principles. So yeah, lawful, ethical, robust, that's not a surprise. I mean, we have seen that in other ethics frameworks as well. But again, for me, the key point here about these guidelines is not so much the content, which is very consistent with what we've seen elsewhere. What I find very attractive about this is the process that they apply to operationalize it. 7 key requirements. Again, this is just another way of sort of presenting it. Nothing new, really. Human agency and oversight. robustness and safety, privacy and data governance, transparency, diversity, non-discrimination, and fairness, societal well-being, environmental aspects, and accountability. All of that is you can find in many of these guidelines. I quite like the accountability part, actually, number 7, because that's also very much in line what the PwC and IMDA here in Singapore have been promoting, accountability-based frameworks, which means that it shouldn't just be ticking the boxes. It's really about taking accountability, being accountable against your stakeholders on what you do with AI. How do you demonstrate to your shareholders, to your employees, to your partners, suppliers, buyers, that you're using AI in a responsible way? And that's, I think, could be an exciting field of business as well. Because as more and more companies are deploying AI, there will be, in my opinion, there will be a place for auditors. There already are auditors out there, but I think this could become a much bigger business when the regulators step in, which they may do at some point, and say, these types of high-risk models need to be audited. And then they designate a certain auditors or some audit methodology for AI. That's not there yet at all, but I can see something like this being developed in the next 5 to 10 years. And so that could mean that new types of auditors, which may be different from the financial auditors, find a new business model and come into this area of auditing or giving third-party assurance over AI. Technical assurance, but also then outcomes, fairness, transparency, and so forth. So the EU guidelines were published in April 2019, and then just a month later, the OECD published their own principles, which are quite similar. The special thing about the OECD principles is that they were actually adopted by governments, not just by the OECD member countries, but also by other governments. So that's, if you look at the European Commission guidelines, they're really more for companies. If you look at the Asilomar principles, they're really more for AI developers and researchers, but these OECD principles are meant to be adopted by countries as sort of a guiding principle on how to use and govern AI in their countries. If you look at the contents, it's very similar to what we have seen before in the European Union guidelines, and that's obviously a good thing, because you don't want to have different organizations to have widely different views on AI ethics. And in fact, what these authors here did in this paper, which was published just a few months ago, is they looked at different guidelines and compared them and tried to extract common themes. And they came up with 5 themes. So that's something now that I find very helpful, because when I go to companies or when I speak to students about AI, I mean, 23 principles is too much, and even 7 principles is still a lot. So if you are able to kind of condense that onto 5, that's much better. So that's what they were able to do, not just from the European Commission guidelines, but also from OECD and from the Beijing AI principles, which were published in May 2019, just a few days after the OECD principles. And that's good, because that also shows that ethical AI is not just a concern in sort of the Western sphere, but is definitely something that is also being promoted in China as well. And so I think it was important, or it is important, as we go along and do research on ethical AI, that we see this as a global problem, not something that is just in one part of the world. These are all things that will impact everyone on the planet. So I think it does make sense to think of this in a global way. So what are these 5 themes? I will explain them on the next page: beneficence, non-maleficence, autonomy, justice, and explicability. And they were mapped, as you can see here, from these other principles, from these 3 guidelines. What do these 5 themes mean? Beneficence, we've come across this in different parts. It means do only good, so promote well-being, dignity, sustaining the planet. This is really about creating AI technology that is beneficial to humanity, good for humanity. But then, in addition to beneficence, we also need to talk about non-maleficence, which means not doing harm. If you just do good, then there is no guarantee that you will also not inadvertently maybe do harm. So this is about all the various negative consequences of either overusing or misusing AI technologies. And privacy is obviously a big concern as within this, where privacy infringements have happened or are bound to happen as big data and AI are more widely adopted. Autonomy means how free are you to do what you want to do, and how is that freedom and autonomy impacted and reduced and diminished by algorithms. That kind of goes back to what I talked about before, where especially social media has been shown to play with our minds, and it's designed to be addictive, and that affects especially children and teenagers who are kind of drawn into these virtual worlds and spend hours and hours on TikTok and other sort of social media. So that's one example of, do we want that? Do we want that to happen? Well, you could say that, it's everyone's choice to kind of do what they want to do. But I think we just need to be aware that there is a trade-off. As we use AI more widely, we may lose autonomy. Another example is, a very simple example about, once you have started using maps to find your way, you lose your ability over time to navigate without maps. And I'm probably speaking on behalf of many of us who have sort of got lost somewhere and then didn't have their phones or didn't have a signal and they had to find their way without a map. If you're navigating with Google Maps or Apple Maps all the time, then you just may lose the ability to navigate otherwise. So that's you kind of lose your autonomy of moving around freely without support from technology and AI. Justice, that's promoting prosperity. Unfairness is obviously a big point here. How do you design algorithms to be fair? And then they call this not explainability, which is the word that you often use. They call it explicability, because they argue that it's not just about explaining how it works, so intelligibility or interpretability, but it's also about accountability. Who is responsible for the way it works? I quite like the way they put these 2 things together, because I think that's quite relevant. It's not just about knowing how something works. You need to know who is in charge. So that's good, and it turns out that these 5 principles are closely related, in fact, mostly identical to traditional bioethics principles. So when I say bioethics, I mean, for example, medical ethics, that has a long tradition, a long history of ethics. Beneficence, non-maleficence, autonomy, and justice are long-standing principles in bioethics. Explicability is something new. It's not something that you need in bioethics. It's really specific for machine learning, explaining and accountability. So that's a new enabling principle. They call it enabling principle because if you have explicability in your system, so if you know how it works and you know who is in charge, it will be much easier to then foster beneficence, maleficence, autonomy, justice, the other 4 principles. So that's good, right? So we have consensus on the principles, and we can say, well, we have a long-standing history of medical ethics or bioethics. So AI is probably not so different. But then some authors say, well, not so fast. It's not the same thing at all. So this is from a paper that was published at the end of 2019, which was called Principles Alone Cannot Guarantee Ethical AI. I'm just summarizing the abstract, but it's really a great paper to read if you're interested in machine learning and ethics. So the author says that, okay, we now have more than 80 initiatives. In fact, right from you now, there are more than 100 that have produced various statements, high-level principles, values, tenets to guide the ethical development, deployment, and governance of AI. And then he refers to the paper that I just showed you before, where they did this meta-analysis and found that this converged on these 5 principles, so the 4 classical principles of medical ethics, plus the new enabling principle called explicability here. However, he then says that that may not be enough, right? Because medicine and AI development are very, very different fields. And many of you are AI developers, so you can probably support that statement. Why is that so? So why is AI development not yet at the same stage as medicine? 4 reasons. Number 1, if you're a doctor, or to take another example of a highly regulated industry, if you're a lawyer or an accountant, you have fiduciary duties against your patients or your clients. And if you violate these duties, then you can be held accountable. As an AI developer, you have no fiduciary duties against users. I mean, how would that work? In medicine or in law or in accounting, you have long histories of professional standards and norms. That's just not there in AI development because it's a very new field. In medicine, in law, you have proven methods to translate principles into practice. We don't have that yet in AI. However, as I will show you in part 2, there are many intelligent people and organizations who are working on making this happen. And then accountability, I think this has to do a little bit with the fiduciary duties. So, you know, if you're in a regulated profession, then you are accountable. You're personally accountable for the recommendations you give. If you're a lawyer, you can be convicted. If you give false claims, or if your advisory does not correspond to standards that are in place for the legal profession, none of that is in place for the AI development profession. So as a result, we should not celebrate too early. More needs to be done. And I would agree with this statement. So that's the end of my presentation for today. And let's now open the room for questions.
Right, thank you, Professor Andreas. Thanks for covering the wide landscape of AI ethics and governance, and also the history and the different voices in it. So we have a couple of questions. So Professor, which one would you like to address first? Or could I suggest this one? How do companies in Singapore think about the AI risks that you have outlined?
Yeah, that's a good question. In fact, there isn't a lot of awareness, I would say, about what the risks are, especially the more existential risks that I showed you, or more security or adversarial attacks. The 2 topics that always come up in almost every discussion I have with companies here in Singapore is explainability and fairness. And I would probably say that explainability comes up more often. How do we understand what's happening? How do we explain it to our management? How do we explain it to clients? What does this machine learning model do? These are real concerns that need to be addressed somehow. Then, of course, you can tell, well, there are local and global explainability methods, but that's not really what they want to hear. You know, it's already too complicated. So that's, I think, of all the risks that I talked about today, explainability and fairness are the two that I hear about most often.
All right. So maybe let's move on to the next one. There's one question related to the autonomous vehicles that you mentioned in your lecture. So it's quite a long question. I will just read it out. If we give the car owner a choice to set the car's mode to either sacrifice the driver or the pedestrian, would that solve the issue? It will be what the driver would have done anyway in a manual car during an accident. Or to make the question more generic, why should the onus of deciding what to do during tough situations fall onto the shoulders of AI engineers? If we give the user a choice to decide and they make the settings before using the product, would that place the onus of ethical decision to the user then? We provide the tool, but it is up to the user on how they want to use it.
Yeah, maybe that's what will happen, right? Because if we cannot agree on a common standard, then maybe we have to give the choices to the users, or we have to randomize it somehow, especially if, you know, if the dilemmas are very close. Although, if we think about this more globally, is that really what we want to do? Because what the car owners would do in this case is probably they would also use the settings to protect themselves, which wouldn't be consistent with the utilitarian principle, and which would, if you add it all up, probably kill more lives than if we had sort of a consistent utilitarian setting, right? So I'm not the one, obviously, to make that call, but this is just something that you have to take. There's a trade-off, right? You give this choice to the owners. They will choose to, as we all do, as human beings, they will choose to protect themselves. But if you add it all up, it may lead to more deaths on the roads than if all the cars were programmed to follow this utilitarian doctrine. So yeah, I know I have many conversations about this with students, and there's no right and wrong really in these situations. These are ethical and moral dilemmas that probably just cannot be solved. And we also discussed at some point, should there be different sort of operating systems in a car, or different ethical systems depending on where you live? So in Singapore, maybe the car will be programmed differently than if you live in the US, which has different, slightly different moral culture. Maybe that's one way to go. I really don't know. It's an interesting subject, and definitely something that will be discussed more in the next 5 to 10 years as traffic and cars move to autonomy.
So we might even have different decisions being made in different areas of jurisdiction, right?
Yeah, it could be.
Okay. Yeah, you mentioned about the ethics frameworks. There's so many ethics frameworks. So this question is, which ethics frameworks are the most widely acknowledged right now?
I would say that among the companies that I speak to, they may have heard of the OECD principles. If they have a base in Europe, they may have heard of the European Union guidelines. But I would say overall that the acknowledgement is not very widely there yet. I think there's still, so most clients are still, they hear this for the first time. I mean, they know that they have heard about fairness and explainability. That's at the top of everyone's mind if they have read about AI. Maybe they are concerned about superintelligence if they have read some books in the popular press. So we can talk about that. But then again, I think there are probably more pressing concerns. So I would say, I mean, here in Singapore, I would say the FEED principles are very well known. Fair, ethical, accountable, transparent principles in the financial services. But I would say the FEED principles, again, are not I wouldn't really compare them to the EU guidelines. They have a different purpose. They're much more about how do you use AI in a bank, in an insurance company. And the same applies to the PDPC IMDA model AI governance framework, which is not an ethics framework. It's more about what should we do? What kind of steps do we need to implement in our company to use AI in a responsible way? And so my second lecture will actually be much more about these kind of considerations based on ethical guidelines and an ethical understanding of the world. How do you translate that? How do you operationalize that into processes, governance, rules, procedures, and all of that? So yeah, to answer your question, I would say the ethics frameworks are not very widely known yet. Maybe OECD or G20 or EU, but companies are much more interested in, and I can't blame them for that, they're much more interested in what should I do? What do I need to implement? You know, give me a checklist, ideally. But I'm always a bit critical of that because I think, in my understanding, AI ethics and governance is much more than just ticking the right boxes. And I'll try to bring that point across in part 2 of my lecture.
Okay. Moving on, software development has been here for decades, and a software error could have equally big impact. For example, Boeing. You mentioned lawyers, accountants having regulation because they have been here for a long time. Doesn't the same applies for software development? Why the focus is on AI and not software developers in general?
I think the difference I was trying to make there is that software developer is not a regulated profession. Everyone can become a software developer if they have the right degree from the right university. If you want to be a lawyer, however, if you want to be an accountant, you have to be accredited. If you want to be a doctor, you have to have an accreditation to practice as a doctor. That's why these are called professions, whereas all of us who are not in these regulated professions just have a job, right? So what do we do for software? Well, even though software developer is not a regulated profession, there are obviously well-established procedures for establishing the safety of applications. If you think of, I think the Boeing example is very, very relevant. If you see what happened with the 737 MAX, which was a software issue, some people say it was an AI issue. So maybe more testing should have been done there. But I think in traditional software development, there are well-established procedures on testing and then release into production. And obviously, all of these apply to AI as well. But I think the big difference between traditional software development and machine learning is traditional software at some point is developed. It's there. Obviously, it's then patched and new releases are put into existence and implemented, but it doesn't change significantly. Whereas machine learning, I'm exaggerating a bit, but obviously it continues to learn, it continues to grow through its interaction with the environment, through new data that's being fed. So in a sense, machine learning is more difficult to control because it's not just about the software and the algorithm, it's all about the data, it's also about the data and the interactions with the environment. And that's even more pronounced when you move from just software to robotics, so to embodied AI, where you have even more sort of safety critical elements. So I guess the short answer is, if you're a company and you have existing IT and technology governance in place, that's great. You don't need to dismantle this. You don't need to build parallel structures for AI. What you should do, however, is you should think about how you can extend your existing technology and IT governance to account for AI. And one big topic in AI always in companies is data. So it's almost like you need to have a consistent view across your tech governance and your data governance. But if you're a big company and you have done your homework already, chances are that you have these governance structures in place. All you need to do then is enhance them for AI.
Right. Okay. Next question is, I cannot agree more about the point about fiduciary duties, but this is probably not a simple and straightforward issue to tackle. It probably needs some legal and political alignment too. Does Professor Andreas see anything happening in this aspect anywhere in the world?
Outside of the academic world, I have not seen anything, no. But then I'm actually quite encouraged by what AI Singapore is doing. The certification program that you're now putting in place. I think for me, at least, that's a great first step towards making AI into a profession, AI development into a profession. So I think you are probably at the forefront of this, but to be honest, I haven't seen other initiatives that are similar to what you are doing. If you do know of any, then I would be interested to find out, because I'm quite interested in this policy making on AI development.
Right. This AI certification is something that we have just introduced this month.
Yeah, I saw that. It's a great initiative, and it really very much aligns with my own thinking and what I was just presenting about the limitations or the dangers of sort of unregulated AI development.
Okay, so okay, I think we have two more. You missed out anything? Okay, this one is, what additional AI risks might there be that we are not aware of yet?
Well, if I knew, right? It's almost like I would like to ask the audience what other risks. I mean, I've given you a long list of risks, but I'm not an AI developer. I look at it more from a business perspective. What else is there that we don't know yet? I think the difficulty here is really that if we look at the trajectory that AI has taken in only a few years, if you think just what happened in deep learning since about 2012 in convolutional neural networks, so much has happened. We've made so much progress in just a few years. Can we even imagine what will be there in 5 to 10 years? What additional risks there might be? I don't know, but I think the book by Stuart Russell, which talks about more of the long-term risks, where I quoted the parts, to me that's a good guiding point on how to think about risks from AI in a more general way, not just on the more technical topics of fairness, explainability, and so on.
Yeah, when you consider that even the big players like Amazon have made some mistakes in the past, so we cannot overestimate our ability to consider all the risks that might be out there.
Yeah, exactly.
Yeah, I think this is probably one of the 2 more questions to go. If there are no more, I see more questions coming right now. Okay.
Okay.
What are your views on the use of AI for surveillance of private individuals? Are such applications ethically justified by public safety, or does this create too much ground for abuse?
Well, it's a very timely question, right? Because we see a lot of this happening now in the public domain as a response to the COVID-19 crisis, where governments aided by private companies are now trying to use surveillance technology, including AI, facial recognition, to detect and track, and surveil people, not just those who are infected, but also those who are potentially or suspected to be infected, or even those who have come back from vacation. So I feel ambivalence about this, because on the one hand, technology has its place, or has its role to play, probably. But there's a risk that once we have left the crisis behind us, that this will just stay in place, that all of these surveillance measures that are now being implemented, not just by governments, but also by companies, that this will just become the new normal, as people say. And that gives me a little uneasiness if I think about the ramifications for privacy and maybe even human autonomy. So to me, I'd much rather have something that is open source and where I can go and view the source code if I need. I'd much rather have something that is decentralized than something that is owned by technology companies. So if you look at the different models for contact tracing that have been developed across the world, some of them are decentralized. There is a European protocol that is much more, in my opinion, respects privacy much more than if you use something where you have a big pool of data that is owned by either governments or private companies. But I think the Trace Together application that Singapore has rolled out, the source code has been made public. People have had a chance to look at it and to see that, yes, indeed, the data is encrypted. The data is only stored locally, unless I decide to upload it to MOH. So I think that's probably a good example of how technology can be used in a responsible way. But I'm a bit worried that, with so much anxiety in the world about the ramifications, and with still probably a year or 1.5 years to go until we have a global vaccine, that people, companies, governments may overreact and implement surveillance technology that at some point just becomes standard, that will stay with us even once we are all immune and once the virus is gone.
Maybe there's one area where privacy preserving technologies need to keep up with.
Yeah, I agree. So I follow the research on privacy preserving technologies very closely. And so I think I see great developments there by the big companies, but also by private actors and by research labs on privacy preserving machine learning or technologies, federated learning. I think these are all great developments that are happening and that hopefully can be applied to solve some of these dilemmas between wanting more control, but also keeping data private.
In fact, even in AI Singapore, we do have a team working on federated learning. So we hope to see the fruits of their development pretty soon.
Yeah, well, in fact, the first conversations I have had with AI Singapore many months ago was about federated learning, because I kind of started talking and I got interested in what you were doing on that, and because I also had done some work and research on that. So yeah, it's great to see, and these are topics that are in great demand, and I think now with the crisis and the use of data and AI will become even more important as we move along.
Yes, certainly hope so. Okay, this is a question from me actually. What tools are available for fairness and interpretability?
Many, as far as I know, and probably some of them are also used and developed here at AI Singapore. I would suggest that I give you an overview in my part 2, and I'll probably focus on IBM and Google and Microsoft, because these tools are the ones that I know best and that are widely documented. I mean, IBM put out Fairness 360 and Explainability 360, and in fact, Microsoft, I don't know if you saw that, just 3 weeks ago, actually, or 2 weeks ago, put their own responsible AI tools on the Azure cloud. So we have tools there now, open source and available to download or to use, that allow you as a developer to work or to make your models fairer and more explainable. So that's great to see. I like this initiative. So I will mention this a bit more in part 2 of the lecture, where I talk about governance mostly, but also a bit about tools that can be used and that are being used already.
Okay, I think I almost missed out one question because it was placed in the chat instead of the Q&A. What key ideas should AI developers take away? I think for developers, they are more in the deploying solutions space rather than this research space. So what are the key ideas? Probably from this morning's session, on 90 minutes of lecture, what are the takeaway points that you would like developers to have?
So I think that the Model AI governance framework that was published here in Singapore is a good way to start to have conversations with clients about AI deployments in a responsible way, and about high risk versus low risk models and what you should do. I quite like that. It's simple, it's approachable. It doesn't just talk about ethics or ethical principles, but really about how to operationalize that. So that's, for me, one key recommendations, especially for AI deployments, because companies, I think we need to be aware that the companies that we speak to that are our clients when it comes to AI deployment especially, don't know much about ethics, and maybe they don't need to know all of that, but they are looking to us for guidance, and they're looking for us to help them deploy AI in a responsible way. And if we can show them sort of these 2 or 3 easy steps, if we can build a POC, show them that it can be done, that they can build sort of basic explainability and accountability, I think that's great. That's what's needed. You know, you don't need to go and do a multi-million-dollar project and build the perfect model. In fact, most of sort of development and advisory that we do is more incremental, where we start with a simple POC, show that it works, and then roll it out. And so I think it's all about trust, right? So companies, executives, managers, they need to not just trust AI, but also trust us as advisors, that we know what we're talking about and that we have the right tools, and that we can help them deploy AI in a responsible way. And if we do this sort of in small steps and use the existing frameworks, I think that's a key message. Do not go and develop your own ethics framework. That makes no sense. There are hundreds of them already available. But build a tool, build a solution, show that it works in practice with real data. If you can do that, both as a company, as a developer, as AI Singapore, then that's all that's needed, really.
Right, that's all the questions that we have today, and we are right on time. Oh, sorry, I think I just saw another one just come in. Yes. What are your views on the use of AI? Oh, no, this is already gone through it. Okay, no, I think that was it. So we are on time today. So thank you very much, Professor Andreas, for sharing so much with us today. So we look forward to part 2 from you. And to everyone, thank you for attending. We hope to see you soon. So stay safe and goodbye.
Thank you very much. Goodbye.
Thank you. Bye-bye.